Hello, welcome to Algebra 2. So let's go ahead and get started. This class is very empty without you guys. I do miss you guys. I hope you guys have been having a good time quarantining yourself over there. Here we're still stuck in the school. So if you can see, these classrooms are very empty without you guys. So let's go ahead and get started. Lesson 61. That is page 436. I am not going to do all the lessons. I feel like for the first example, we've done it before. We've done it a couple lessons ago. It was synthetic division. Just go back to that lesson. If you don't know where to go back to the lesson, go to the table of contents. It's like probably one of the first couple of pages. I'm not going to show you my book, but it's one of the first couple of pages and they show you the lessons there, and you could just go back to it, or you can just look at example 1 and see what they've done. What is new in this lesson is the other examples. So we're going to learn two different types of factoring. So here, I'm going to go ahead and move this to the side. We have two different types of factoring. We have the sums and difference of cubes. We'll do that one first. Sum and difference of cubes. Remember, A and B, the difference of two squares, A squared minus B squared. A is the first term, B is the second term. So that means A minus B times A plus B. That means first term minus the second term times first term plus the second term. Here, A and B means the same exact thing. First term, second term. But now we're dealing with cubes. So here, A plus B, A cubed plus B cubed is equal to this equation. This is on your book, so this is on page 437. If you see me swiping like this, that means people are emailing me questions, different things. If you have any questions yourself, down here, there's going to be a little box so you can look for my email address and go ahead and email me. I prefer you guys email me than anything else. But if you have any questions, I will for sure try to respond as fast as I can, unless I'm actually recording a video myself. But let's keep on going. So example 2, A, pretty self-explanatory. Let's do B. So 27x to the 6th power plus y to the 9th. Again, for the difference of two squares, we have to make sure it's instead of first term squared minus the second term squared. So this same concept. It's the first term cubed plus, so we're dealing with the sum of a cube, plus the second term cubed. So we have to kind of undo this and put it in terms of cube. To undo it, you're going to cube root each of the numbers there. So here, the cube root of 27. So what times what gives you 27? And that's the magic number 3. For exponents, I have right here, this goes back to the rule. So we have the nth root of x to the a power. That is equal to your exponent, x to the exponent, divided by your root. So it's your exponent, 6 divided by your root. And that is squared. To double check your work, 3 cubed, 27, x squared cubed will give you x to the 6. So now the second terms, we have to cube both terms. There's only 2 terms. When you cube the second one, again, it's the exponent divided by the root. So 9 divided by 3, you get y cubed. So that means your first term is equal to 3x squared. Your second term is equal to y cubed. Keep in mind, it's not the cube cubed. It's just what's between the parentheses. Now we follow this equation here. All we do is exactly copy it how we see it. It's a cube, so first term plus the second term. 3x squared plus y cubed. And then times first term squared, so that is 3x squared, squared. So remember, your first term squared, I'm going to put brackets so it's not too many parentheses. First term squared, looking at this, minus your first term, 3x squared, times your second term, which is y cubed. And it says plus your second term, which is y cubed squared. And then you go ahead and solve. So for this one stays the same, plus y cubed times 3x squared squared. So you squared both factors between the parentheses. So the 3 is squared, so that's 9. And the x squared is also squared, so that means it's going to be 4. You multiply the 2 exponents here. Minus 3x squared times y cubed. It just combines all together. And then here it says y squared squared. That is equal to y to the 4th. You're multiplying them. Remember, you're not adding them. Now, let's do the second one. Right here, C. So here we have 3m to the 5th power minus 24m squared. Keep in mind that there's one rule that you always apply is when you're factoring, every time you always factor out a common factor. That is the number 1 factoring. factor the common factor, I'm writing fast, first. You always do that first. The other ones, we couldn't factor anything out. So here, there's a common factor here. The common factor here is 3 for the number, and it's m squared for the variables. Again, if you don't know how to do that, go back to the lessons and see. We've done this, this was probably in the beginning of the year. Now, when you factor that out, we end up with m cubed minus 8. So now, we can't just say we're done right here because m cubed minus 8. Keep in mind, this lesson deals with sums and difference of cubes. So you have to think, hey, is this dealing with cubes? Is this dealing with any other sort of special factoring? Is it trinomials factored by errors? Is it anything like that before I can say this is my final answer? In this case, m cubed, I see the 3, I always think of cube. 8 is also a perfect cube. So if I were to take the cube root of each one, I can go ahead and have my 3m squared. I'm gonna do this. I can find my first term and my second term. Again, your first term is not m cubed, your second term is not 8. You have to kind of undo it and put it in terms of cube. So your first term here, if you take the cube root of m cubed, you're left with m. If you take the cube root of 8, you're left with 2. 2 times 2, 4 times 2 is 8. Now, looking at this, it's a difference of a cube. So now we have our 3m squared from our beginning. Then we have, again, we use brackets. We have here, it's the difference. So your first term minus your second term. So m minus 2. Times your first term squared, m squared, plus your first term times your second term. So your first term times your second term, 2 times m. And it says plus your second term squared. So it's 2 squared, and that will give you 4. And that is your simplest form in factoring. You're not going to multiply anything out. Remember, factoring is the opposite. You're trying to separate them as much as possible. So the more parentheses you have, the better it looks. So here, that is our final answer. Next one, group factoring. I actually like group factoring. All you have to do is you factor 2 sets. So here we have 4 terms. So when you're factoring 4 terms, you're separating them into 2 sets. So when you separate them into 2 sets, you factor the first 2, you factor the second 2. So now, if I can move this here, we have x cubed plus 5x squared. You always factor a common factor first. So the common factor here is x squared. When you factor out the x squared, you have x plus 5. Second one, we have 3x plus 15. You can factor out a 3. So not only are you putting a 3 there, you have to put the sign of what that is. In this case, it's a positive 3. So when you factor out a 3, you end up with x plus 5. If you notice here, there is a common factor here. We're still factoring out common factors. There are still 2 terms. This is one term. This is another term. They have a common factor. They have a binomial in common. So that means when I'm factoring those 2 terms, I can factor out my x plus 5. When I factor that out from my 2 terms, I'm left with an x squared, and I'm left with a positive 3. And then looking here, x squared and 3, it's not a difference of 2 cubes. Remember, difference meaning it has to subtract for the 2 cubes. And then the difference of a cube, sorry, I was thinking of 2 squares. So squared, you can't, there's nothing in here. And a cube, again, there's nothing there, so that's your final answer here. B, group factoring, there are 4 terms. You're gonna separate them into 2. So your first 2, your second 2. Your first 2 terms, oh my word, sorry. Your first 2 terms, you wanna see what they have in common. In this case, they have the x cubed in common, then you'll get x plus 4. Here, whenever you have a term that you're factoring and the first term is negative, you have to factor out the negative. In this case, there's no factors in common. When you factor out the negative, this negative x divided by negative 1 turns into positive. Negative 4 divided by negative 1 gives you a positive 4. Now they have a factor in common. They have this factor and this factor. So when I factor that out from the 2 terms, this is one term, this is the second term, I am left with x plus 4. And then I have x cubed minus, and this minus sign here, it's not just a minus, it's always a 1. Whenever there's like a negative sign in front of it, it's always representing negative 1, the understood one. looking here, this is not simplified. X cubed minus 1, that is a difference of 2 cubes, but in this case, they are in terms of cube. 1 cubed, you can take the cube root of 1. What times what gives you 1? Okay, so I cut off, sorry. Here, we take the cube root of each one. Your first term is equal to x, your second term is equal to 1. So now you have your x plus 4, that's from what you factor here. But now you're factoring this whole term here. So you have your first term and your second term. This is the difference of a cube. Now we're looking here. First term cubed minus your second term cubed is equal to your first term minus your second term, x minus 1. Then you have the whole trinomial. The first term squared. X squared is just x squared plus your first term times your second term. X times 1 just gives you x again. And then your second term cubed or squared, or 1 squared is just 1, and that's your answer here. Here you can't find factors of 1 that will give you b, find factors of c that will give you b. In this case, that's the answer right there. One last one and we are done. Sorry, this is a little bit longer than usual, but see. 1, 2, 3, 4, 5, 6. We have 6 different terms there. We have to divide it and factor into 2 sets. So divide 6 by 2, you get groups of 3. So let me use a different color. Let me use red. So now we have the first 3 and the second 3. So your first 3, you find numbers to factor. You factor out common factor first. Your first numbers here, you can't factor anything out. But you can factor out a variable. I can factor out x to the 4th. And when I factor that out, I get x squared plus 3x plus 2. Looking at your second one, you can't factor anything out. You just leave it as plus x squared plus 3x plus 2. Again, always keep in mind, put that plus sign there. Even though we're factoring the first 3 and the second 3, you always try to put a plus sign or minus sign in between the 2 you're trying to separate. Now, we go ahead and look at this. We have one term here. We have another term here. They have something in common. They have their trinomials in common. So therefore, if you factor this out, x squared plus 3x plus 2, you are left with x to the 4th power plus, and there's nothing there. That's always an understood 1. The 1 is never being understood. And that's it. There's no fourth cube or anything like that. It's just squared and cubed. But that would be your answer. You can't really simplify that more. Actually, you can. Sorry, I lied. You can, because this trinomial, you can find factors of 2 that equal 3, and that's the factors of 2 and 1. So now when you're factoring this whole thing here, you'll have x plus 2 and x plus 1, and you just bring this one down, which is x to the 4th plus 1. There's no proper order you have to put these in. As long as you have 3 binomials, you are good. Or maybe 1 binomial and a trinomial, but you're good. If you have any questions, go ahead and email me down there. Again, be patient with us. We're trying to do the best we can with our quizzes. I love you guys. I miss you guys. I hope to see you soon.